Hello, everyone. Thank you for being there today. I'm Aurélie Baker. Today, I'm really glad to welcome Jean-Philippe Beaujard from FlightWatching. I just give you some context about this webinar. So I'm the Nexus France manager, and we existing since 2030, and we have almost 50 alumni, and we decided this year to make a series of webinars to highlight our alumni. And FlightWatching is one of them. And I'm really glad to let the floor to Jean-Philippe today to introduce what they are doing.
Okay, thank you, Aurélie. So it's a pleasure for me to participate to this webinar organized by ESA, a business incubator. It was a couple of years ago since we joined that incubator, and it's a pleasure for me to provide you some return of experience on our project and where we are today. So I planned to go through how we created the startup and how we started our business, I would say, the first years, to give you as much as return of experience at the start of a project, and what we're doing today too, and to explain you a bit where we went through. Okay. So when you create a startup, you definitely have to solve a problem. Okay, so in this slide, I'm illustrating the problem that we are solving, and the one that we had in mind at the beginning of FlightWatching. So in 2014, as you should remember, there was an aircraft that disappeared suddenly from the radar in Malaysia. That was a Malaysian aircraft. And it's quite astonishing to see how such a high technology, like an aircraft, can suddenly disappear in a world where we're so connected. So we don't even know where it crashed today. We still didn't find it. And we didn't even know where it went to. So how can, in a world where we're so connected with internet and satellite communication, have such a situation? That was quite astonishing. But let me go deeper in that. So the last radio contact that we got from the crew was at 1 o'clock in the morning, around 1:19. Yeah, that was a communication to ground control. Okay, but aircraft don't just send radio signals through the cockpit, through the pilot. They also send automatic data to the ground, and the pilot doesn't even know about it. So it's automatic reports called ACARS reports that are sent automatically to the ground and that are transmitted through satellites or ground radar units through radio signals. And it's a communication that exists since the 1990s, even before, I think. So it's an old communication, and it's a well-known protocol, and all the manufacturers in the world use this protocol and use these automatic reports. One month after the aircraft vanished from radar signals, the CEO of Rockwell Collins, Kelly Ortberg, at that time, mentioned that we may have to write some software, but we definitely have the technology on board. That means that the aircraft are already equipped with means of hardware that allow continuous tracking of the aircraft, continuous information of health of the aircraft, but we just have to write the software. And that's what we wanted to do at FlightWatching. We wanted to build that software to allow to continuously communicate with the aircraft and create warnings in case of a problem. An alert that would be sent automatically to the ground without any notice from the pilot, even that he doesn't know about it. It's using that same protocol, the 8 cars protocol. So that was the problem we were solving at that time and still today. My name is Jean-Philippe Beaujard. I worked 7 years at FlightWatching, and I created the company with Olivier Hodac, who also has founded the company. And we've been working at Airbus before in Toulouse, south of France. I've been working at the flight test department for a couple of years and about 16 years at the design office on avionics. So we came from the technical side, both engineers. We didn't know how to sell anything really, but that was the starting point. We were very complementary. Olivier had the IT experience, whereas the software guy, and I was more the avionics guy and the aeronautic guy trying to solve that problem. Before making the big jump in the void, we were quite inspired by Felix Baumgartner at that time. You know, that was before we started the company, just thinking about our project. And one thing that we had in mind is you got to be well prepared to make that jump. So you got to be, I would say, in your mind, well prepared, because you're definitely, even though you have a good relationship with a lot of people, when you create your own company, it's a different story. So that was quite inspiring for us, and we decided to make the jump in April 2013, where we planted a seed, really, of the project, I would say, and that was the beginning of our story. But you know, to make it grow, to make your project grow, you need to water it, and water in business is money. So you really have to focus on seed money at the beginning of your project. At the beginning, when we created the company, that was even before, because we quit Airbus, I think it was in January 2013. And in February, we were selected by Toulouse incubator called Nubo now. At that time it was Midi-Pyrénées incubator. And that was really interesting, because people got interested in our project. There was a selection, so it means that it may be a good project, you know, so it gives you encouragements. And there were about 7 startups selected at that time. They offer us an office and, of course, some seed money to start the project. But it's a tough world, because since 2013, they're out of the 7 startups that you see here. Well, there are a couple of guys on the picture, but the young guys are mainly the startup guys. At that time, I was a bit younger. Only 2 survive today. Okay, so it's quite tough, and you know, in 7 years after, only 2 remain. Okay. So at the beginning of the project, we were working on different ideas. You know, you have to be flexible. So I sort of illustrate these ideas through the different icons, the logos we went through. So we were thinking about something innovative, disruptive to do, something really different. And then one time you come up with an idea, yeah, let's work on real time and things like that. And then one day you come up with an idea of a project and a logo. You know, you work a lot sometimes on the logo. Sometimes it's a waste of time, but you should work on the project more. But at the beginning, we had that idea. We thought it was the best idea, and that nobody was doing that before. And at that time, we were a bit wrong. But you know, we had to start with that. So what happened? In France, there are national contests where you can get granted money from the government. They grant you money, so that's very interesting for us. And we were selected in 2013 by summer through a contest called iLab Now. And this is a global picture. So you get to meet people that you never would meet before in your old company. I mean, this is meeting, ministers or, people like that. So that was interesting. And we got a lot of money from that project that allowed us to finance the project through more than a year. But we continued to seek for seed money. And we were supported by EADS, which at that time was the mother company of Airbus. So now it's called Airbus Group. So it's a bit equivalent to the Airbus Business Lab. At that time, the Airbus Business Lab did not exist. And we got some extra seed money from that organization. So they supported our project too. That was really great. So we kept getting more and more seed money, and the region helped us with great support. It was not just money, but was also support and trust in our project. Because you need, as you're starting from nothing in our project, you really need also some support in people that believe in you. Okay, and this was the case from La Région Occitanie, who supported us faithfully in events, shows, and that was a great moment. ESA was also a great support at that time. That was in the beginning of 2014, where we were selected, and it was more than the label, because it was really very interesting. Mainly, I would say what I remember the most is the invitations at the ESA pavilion at the Paris Air Show. So here's a picture in 2015. I think we were invited 2 years after too. That's absolutely fabulous, because you get to invite your customers to a great pavilion. You're not in all the booths, the small booths, in Hall 6 of the Paris Air Show. You're really at one of the best pavilions at the show. That was a great event, and we got some traction on this event thanks to that, and that was really great. Another path we followed in 2014 was I think it was organized by the Minister of Foreign Affairs, and we were selected to present our technology in the United States. The project's still called NETVA, I think. It's great. It's a package where you train to pitch, you train to prepare the American market, and that was absolutely fabulous. We got to meet the incubator called 1776 DC, and we participated in Challenge Cup. And that was a great event too, and helped us to definitely say that we were not prepared to go to the United States, at least at the beginning, so avoids a lot of waste of time, energy, and money. So we were sticking our market to Europe and the Middle East at that time. And finally, the Galaxy Club, which helped us to where we won the grand prize. They organize a yearly contest every year, and there's one this year too for startups. It's in relationship with a museum in Toulouse, a space museum called La Cité de l'Espace. And this is really a club of entrepreneurs, people who have good experience in creating companies. So it's not only seed money, it's also a lot of recommendations to start and what to do, what to not do. And you have some serial entrepreneurs there, and that was really a great step too for us. So at the end of, I would say, the 2 years, we collected a certain amount of seed money, which allowed us to finance our project. Definitely for 2 years, a bit more even than that. We were only 2 guys, and we were just working with subcontractors at that time, and didn't hire anybody. And we decided at the end of 2014 to stop seeking for this type of money, grants or European projects. Maybe we never did that, but we didn't want to go in that direction. We didn't want to go in a path where we were constantly seeking innovation, where you get funding, but you don't really get what I believe is top line income, which is really coming from customers. We wanted to build a product, and that's where we wanted to put our efforts in. So we decided at the end of 2014 to stop seeking for seed money. So maybe the company will crash if we don't get sales. So all our efforts were put on sales in 2014 and 15, and we knew that if it didn't succeed, either we had to pivot or raise money, or we would stop the company. So concerning business during these 2 years, it was quite tough. You know, when you're building a new product, we didn't want to sell services. We really wanted to build something. So we built some mock-ups, some MVPs, to see the traction we could get from our customers. It was not yet ready, but we were able to communicate to it. So this is an example of what the referrals we got. By participating to an MRO event with some big players, you know, we were just a startup, but we were in the regional pole, I would say, of the event that concerned our business. It was an MRO event. We got traction from press, and we got a 2-page article in Aerocosmos, which is a national magazine on aeronautics and space, and that was unimaginable in French, I would say, because, you know, when I used to work in Airbus, you're always very proud when you get a very, you know, minimum square or what you're working on. This time we had a 2 full page in the middle of the magazine talking about flight watching. I think the press liked us, and they liked our project. They wanted to give us a big boost, and they didn't really tell about us, but we were really surprised to see it in the magazine. Another important thing that we did was we patented our technology to make sure that we were not we had the rights to do what we were doing. I remember these patent trolls organizations coming from sometimes lawyers in the United States that could come back. So we really wanted to make sure that what we were doing was in the right direction, and it is also something that gives a value to your company when you're creating a startup, as you know. So in 2014, we got our first contracts, and the first one was one of the biggest company in Europe at that time, EasyJet, about 200 aircraft. We presented our technology, and it was presented to a large press during the innovation days. EasyJet, they wanted to communicate a lot on innovation, and we got our first contract with EasyJet thanks to that. And it was absolutely amazing, gave us really some encouragement. It was I would say, a proof of concept type of contract, but it was really, you always remember your first check, you know, when you receive. So it was quite amazing. And what was even more amazing is that a couple months after, we got 2 more contracts, one from Dassault Aviation, further to the press release in Aerocosmos. We got a call from Dassault, a guy from Dassault Aviation, to work on the Rafale, and we got a contract for that. And Rockwell Collins also, thanks to our network at Aerospace Valley, allowed us to start some work on different subjects. So these 3 contracts were really the proof that maybe we have something great, and trying to put this on the market and to refine it so that it gives even more traction in the future. And the traction came at the end of the year, where a company, which is an MRO that repairs APU, came to us to select us. It was Revima, and it's a French company in Normandy. And actually, we got this customer through a pitch I made in the street to a friend with a lady from Pratt at that time, and that found our technology quite interesting. And when she joined Revima, we were selected to start a proof of concept. So I skipped a couple of years because, in fact, we continued our growth with our customers. As you can see, we made it through these tough years where you don't get any more grants, but you have to work with customers. We actually never rented money too, except the money, the seed money that I mentioned at the beginning. Some were loans, well, not grants. And we kept passing through. We didn't even raise money. We didn't need to. And we wanted to remain quite small, quite agile, to continuously refine our project and make it one of the best. And at the beginning of 2018, we had about 15 different customers that were on our books. And we took a decision because when you grow, we found out that our technology was great, but we were too small to sell it to big players. So some customers told us that your technology is really great, but you don't have the resilience. What happens if your company goes bankrupt? So this led us to some difficulties, and it won't change if you're 10, 20, or just 2. So raising 3 million euros was not a solution. And we asked a lot of people around in the Club Galaxy, for example, and entrepreneurs. And one of the best things to do for us at that time was an exit. So we decided to sell the company because it was really giving quite some traction at that time. And we structured, I would say, the selling of the company with an expert in merging and acquisition and M&A. And so we published our information memorandum in around June of that year. We selected the offers that we received in the summer, just after summer, around September. And at the beginning of 2019, we were acquired by Revima. So that was a quite a unique path at that time. It's really another story going through this sort of process too. And it was also a great opportunity to anchor our technology with a company that wanted to scale in their business. And I think we had the technology to help them. That was a great moment. So if we go back to the data that we were working on, the ACARS data, so I'll explain you a bit more what we're doing, trying not to use the expert words, so that it becomes understandable by everybody. The data that we were working on actually are difficult to access. So you have to have a barrier to entry somewhere when you're a startup. That's the best situation, and the more barriers you have, the better it is. So one of the barriers we had was the difficult to getting access to aircraft data. Not a lot of people know how to do it. It's quite complicated. It's a very old protocol from the 1990s, and it's a telex format. It's an old protocol, but its major advantage that it is working all around the world, and all the companies in the world use this, okay, except some regional flights, but we were not interested in that. And another amazing thing was that there's a lot of aircraft stored in the aircraft and not delivered during flight. and around 1% is really used and looked at, I would say, during flight, and 2% is actually stored, and 97% is actually on board. And our idea was really to use the possibilities of the aircraft without making some modification. So what is this data actually? So you have to know that it started in very long time ago, well, very long time ago, so only 50 years. So in 1977, the first digital words came out just to explain that the aircraft was going out of gate and taking off. So it was mainly used for traffic, okay, to tell traffic control that they were departing, and it was used at that time for the pilot's wages, you know, to the salary, because they were getting more money after takeoff. It was flight conditions, and that was also one of the reasons. So it's automatic. It's not written manually on the logbook or things like that. And that was an American company called Piedmont Airlines that used this. And then it really grew quite fast at that time. And the data then became more interesting. The engine manufacturers were really interested in that technology to gather parameters on how their engines were behaving during flight, because they knew pretty much how they were behaving on ground. And we're using actually the same box that is interfacing with the black box. So our technology is communicating with what we call DMU, and we find these type of boxes on all Airbus, Boeing, Embraer aircraft. You know, all the aircraft had these boxes, and about 3 equipment suppliers designed these boxes around the world. So we became really experts on these boxes, whatever the manufacturer, whatever the aircraft type. We even knew the bugs on the boxes. So we were able to build something quite powerful that was able to collect not only APU and engine data, but all other systems, because progressively this box was collecting tens and thousands of parameters in real time, okay? So we've, that too was a sort of a barrier to entry. And the one thing we decided to use was to use them in real time. So there are about 10,000 parameters that you could explore through radio signals with aircraft, and only about 1,000 are recorded on the black box. So in comparison, you can see there's about 100,000 in total. But through radio signals, you can explore around 10,000, which is pretty good. So we said we have a smart solution that could enhance existing tools on the market. By using satellite communication, we could interface our servers with airline messaging services and then get some powerful tools on the market to analyze data in real time. You know, at that time, 2013-14, nobody's really talking about big data at all. And we were exploring a bit that field at that time. So on the market, we had reports really old-fashioned. I think this is a Boeing one, and this is a report that the tools gave at that time, and still give you. AHM still looks like that today, and it's a takeoff report. So it's the report I showed at the beginning of my scenario with the Malaysian flight, and you know, I mean, this is quite difficult to understand if you're not an expert. So we decided to do something where people that just know their system can understand, because PKWD, even though you're an expert on the bleed system, you don't know it's the PAC word or, you know, or things like that. So we decided to make it simple. That was also on our platform. That was also our objective. Okay. So the objective was to build a platform that would collect 90% of the data available during flight, and to aggregate it and create different applications very easily. So it's a sort of platform, a sort of middleware where we could build different applications in a snap. That's what we wanted to build, and that's what we did. So the functionalities we performed were around data, to collect them and calibrate them, around analysis, what do we do with the data that's stored on the ground, and how to visualize the results, okay? And the positioning of our company was as important as the product itself. And sometimes you really don't think about that, because you think about your product, it's not perfect. But sometimes you have to figure about your positioning on the market. Where do you want to position yourself through the market? And that was important for us. We decided to position our product as an SDK so that others could build their own applications with their own brand, whatever they want, with using our technology. If we take a look at Visualize, what did we do? We actually designed we didn't find it on the market. We didn't find the component on the market, so we did it ourselves. We wanted to design our own dashboard from scratch through Illustrator, for example, or another product on the market where you could design a schematic that looks like a documentation of an aircraft. So you straight away, you understand what the system's doing, with valves that would turn and things like that, instead of interpreting zeros and ones. We also wanted to simplify the access to data and to allow to connect data very easily. So these raw data formats, we wanted to make it extremely simple to parse them. Okay, so, and the result is actually making data come alive. So with the data that we are receiving in real time, and with the export from Illustrator in a snap, we can, without any efforts, a couple of minutes, we can start making our dashboard react with different algorithms and formulas. So that was the visualization component. And concerning the alert component, we were working on new technologies at that time. So now they're quite common nowadays, but at that time they were not. And we were working on the best components on the market to perform automatic algorithms. So one of them is machine learning. And you can see that here we are, for example, if you take a look at the dashboard where we are creating an alert, there's the yellow zone and a red zone. The yellow zone, I would say, is the alert zone. And you have a couple of hours or days that we can evaluate to go into the red zone where the pilot will get a warning, for example. So, and this is achievable through automatic machine learning algorithms that allow us to take advantage of gathering data and to recalibrate the model with the results that correspond to real failures and things like that. So, as you can notice too, we were inspired by another great website. If you don't know, it's called IFTTT, where all our logics are designed on this concept. So if this, then that concept. So it becomes extremely simple to build your own actions, to create a model, to send a message, to alert, things like that. So all the actions are based on this concept. And concerning the data itself, we connected to aeronautical data at the beginning, but we found out that it would be very interesting to connect to other types of data sources, because the data customers were asking us if we could link to ground equipment, if we could link to sensors or things like that. Orange contacted us to see if we could link to LoRa objects. And gradually, in fact, the platform became very open to different types of data sources. And one of them was the recent one was the webhooks. So webhooks, allow you to link to any type, I would say, of data on the internet. This is an example of real time, really linking the accelerometers of an iPhone with a dashboard that we designed. So it's extremely fast, quite amazing. It's really going through the internet from the iPhone to the dashboard, and we evaluated that technology and optimized it. And so now the platform is really plug and play for any webhook through any webhook. So if you all the applications that have this type of interface, we can in a snap link to it and benefit with our I would say SDK platform. So the idea for our customers was, when they were, a lot of them were having problems with the complexity of the representation of reportings. So, engineers usually make complex reportings and things like that. So our idea was really to make it a bit more simple and allow the reporting to become very easy to people who are pragmatic and work on the ramp or work things like that, and also very easy to understand for management or things. So it was a technology that allowed us to build dashboards, ad hoc dashboards, very quickly, and with the graphical chart that they wanted, and allowed us to avoid training and things like that. So today, the data is really gross data, a bit like this, and it will become, we're using on the market, you have different sort of things. We're not doing business intelligence. We're working on live schematics, okay? So in fact, what we're actually rendering is something completely different. We're not working on data that is like graph charts or things like that, pie charts. We're really rendering with dashboards that look like what the people are used to work on, okay? So for example, Excel formats could have a different shape too, to create alerts. For example, this was a reporting that we injected as we're compatible with CSV formats. You just send a CSV format to the server. It checks it. It checks the validity of the sheet and renders in real time a report for example, here we're talking about, of course, it's de-identified, so as you can see, but we're talking about people that are working on a repair platform or a workshop to report any delay or any if everything's going fine for delivery. Okay. The tool is also renders on mobile devices. It works on a web application, a browser. You just log in, and that's how it does. Hold on. Oops. There we go. So I have a couple of other use cases that I could show you too. The main advantage of our technology is really the time savings to create the applications. So it's very fast and allows to develop different, I would say, versions of your platform very quickly in an agile format. Okay. We actually worked for the space industry too. That was after incubating with ISA, and we monitored live data coming from the ISS with the planning and where the French astronaut Thomas Pesquet was in the ISS. So it was a collaboration with the CADMOS from the CNES, which is a lab that is receiving live data from the International Space Station, in association with the Cité de l'Espace, is a museum in Toulouse that's has some great expositions. And we're doing it again this year because Thomas is going back up to the station, and we will be presenting another dashboard. I think it's a new one this time for different purposes using our technology. So it's live information in a museum. That was fun. The platform can be used for ad hoc data streams like drones or things like that, where we can monitor things in real time. So it could be used for people that want a quick win to present something really great in their technology. So that's also something where a small market where we developed a bit too. And concerning predictive maintenance, we developed it, of course, in the aeronautical industry mainly. So this is an example where we were monitoring a turbine engine called the APU, which is at the rear of the aircraft, and where we could create alerts before a significant degradation of the engine itself. So this allows to create alerts, not necessarily before the pilot reports it in this case, but most important before the system gets degraded and that we can't repair it anymore, what we call BER on the market. So that's, I think I'm at the end of, I would say, my presentation. I would like to thank also the people that followed us that are appearing here on the dashboard. So that some of them which I talked about. And if there are any questions, I'm ready to answer. Here we go.
Thank you very much for your presentation. It was very interesting. So if you have some question, you can ask them in the tools. So you have a question box. So please feel free to ask question. So I have once. So Jean-Philippe, do you have some example of connection between your platform and IoT, or like some use case or something like that?
Yeah, well, we absolutely. We worked with Orange to interface with their IoT objects. So Orange was offering a certain number of IoT sensors for humidity, pressure, temperature, and things like that. And we collaborated together to be compatible with all LoRa objects. LoRa is a network of Internet of Things. And it was, for us, very interesting because we were capable of using our compatibility with these objects to use it in airports and link it to aircraft data that we were collecting at that time. And it was a plug and play option. So in our platform, it's quite open, and we can just register the sensor and we acquire the data straight away.
Okay, so we have another question. What are the monitoring systems in planes?
The systems we're monitoring on the aircraft, there are a couple of systems. Of course, there's the APU. The APU is the engine at the rear of the aircraft that I showed an example, but we're also monitoring different systems and all the systems that are actually providing parameters to monitor them. So we've monitored, for example, the bleed system, which is the pneumatic system that is providing air in the cabin. We're also monitoring the air conditioning system of an aircraft, the landing gear, the fuel system. So, in fact, we were we did not want to create a catalog of systems to monitor. We were more flexible, and we wanted to monitor the systems that our customers wanted us to monitor. So that's why we made the platform very flexible to response to our customers quite quickly, that we could monitor any system using parameters.
Okay, very interesting. I think we have no more questions. So I will thank you for this presentation. It was very, very interesting. Yes, one other. In case of aircraft electrical generation failure, does the system still work on emergency power?
Yeah, so when the aircraft is in an emergency situation, it will depend on what type of aircraft we're talking about. So as we're working with radio signals, definitely the radio signals are on emergency power on the aircraft, because the pilot has to communicate to the ground. So the data is available, but some systems may not. So some systems may be delisted, but the aim of the platform is not related to security. So when you're in an emergency configuration on an aircraft, you're in pretty bad shape, and we're not talking about predictive maintenance anymore. But otherwise, yes, it does.
Okay, so other questions? Each time I try to finish a webinar, some question arrived. Okay, so I think it's okay. So again, thank you very much for your
okay. Thank you very much, and
all of you for being there, and good luck for your upcoming activities.
Okay, thank you very much. Already was a pleasure to participate. Thank you. Bye.
Yes, thank you. Bye-bye.